Okay, this is part 2. Here's Skinny. This is part 2 of the video. Okay, this is part 2 of the video. This is the back of the ramp examples that you should be viewing for homework. Okay, with what minimum force must you push to keep a 30-kilogram object from sliding down a 30-degree incline? So 30 kilograms is mass. I know I have to break weight into components. Got the weight parallel to the ramp and the weight perpendicular to the ramp. The supporting force of the ramp is perpendicular to the ramp. And now friction's already holding it back some, but apparently that's not enough. You have to add a force. So I already have some friction holding it back. So friction's helping hold it back. I just need to add a little more force to make it equal so it stays at rest. I'm keeping it from sliding. I'm keeping it at rest. I need a balanced force. Now this would be a different problem if I said what maximum force must you push? And that means it'd be the maximum force before it actually starts sliding up the ramp. So in that case, friction would be working against me. If I would have friction working down the ramp and I would keep pushing harder and harder and harder until these were equal. I'll probably point that out in class. But for this problem, I have balanced forces, so I'll write equations from the diagram. Weight parallel equals the friction force plus the applied force. These two together equal that one. There's no net force. There's no acceleration. And the normal force equals weight perpendicular. I'll make my little chart. Now you pause the video and try to fill in your chart yourself. Make sure you're looking at a triangle and not just looking at another example. Once you've filled in your chart, hit play again. I hope you didn't use 30 as your hypotenuse. Mass will never be a line on a force diagram. The hypotenuse will never be mass. Mass is not a vector. It's not going to be on this diagram. So your hypotenuse was weight, the 294. I'll start with the equation for my diagram. I'm looking for the applied force. My little equation for friction is mu times the normal. I'm ready to plug in numbers. Weight parallel is on my list. I'm given mu in the problem. Normal force is the same as weight perpendicular, so 255. And I'm solving for applied force. And that's just a math problem. Okay, let's look at the next example. With what force must you push? So we're looking for applied force again. To accelerate. Okay, we do need a net force now. We're accelerating a 25-kilogram object up the frictionless plane. Okay, so I need a net force up the plane. Start with weight. This time you have to draw your own weight. Check. Make sure you're putting it toward the bottom of the paper, straight down. Some people start, going sideways. And yeah, weight does not pull sideways. Gravity pulls straight down. So make sure you have a good start there. And then make sure you have a good looking rectangle. So I've got the weight perpendicular to the plane. I have the component of weight parallel to the plane. The normal force is equal to the weight perpendicular. There is no friction. And if I'm pushing and accelerating up, you must be pushing up. So my applied force is up the ramp, and it must be bigger. Oh no. Okay, this should say weight perpendicular Make sure you add that on your paper. I hope you're listening to this and not just have the sound muted. When I did the screenshot at school, I don't know what happened. But make sure you write weight perpendicular here. And my other equation, applied force minus weight parallel, is the net force. Alright, so you can tell I had another mistake here, and I had to jump around the video. I already filled in my mass is 25. I multiplied that by 9.8, and I get my weight was 245. And now looking at my yellow triangle, you can tell how I broke into components here, sine and cosine. So I cross-multiplied and filled that in my chart. Okay, now I'm ready to take my equation from the diagram and solve. With what force must you push? I'm looking for the applied force. From my chart, I know weight parallel is 104. From my chart, I know my mass is 25. The acceleration of the object from my problem is 2.5. Now it's just a math problem. Pause the video, solve it, and then check. And it's our last example. Notice it's almost the same problem. With what force must you push to accelerate a 25 kilogram object up a 25-degree incline at 2.5 meters per second squared? That's all the same. If mu equals 0.200. So now we have a coefficient of friction, so now we have a friction force. So think about it. Would you expect to get a bigger answer to this problem or the last one? Let's see. Turn my weight straight down, making a good rectangle and good components. Okay, this time I'm accelerating up and there's friction, and friction opposes my motion. So friction is down the plane. So I've got a component of my weight down, but I also have friction down, so I tacked that on the end here also. And I have a net force up. So my applied force must be bigger than both of those together. So remember, you're just looking at the pink forces. This black weight that's not there anymore, I replaced it with these two pink ones instead. So my equations from the diagram. Normal force is equal to weight perpendicular. Oh good, I wrote it right this time. And my other equation, think about that. Think about that and try it yourself. Okay, it doesn't matter what order you wrote these in, but I do like you to subtract them both separately instead of like using a parenthesis. Instead of using a parenthesis and adding these, because then when you substitute in values, you'd have to remember to distribute. I like to just write it out separate like this. The applied force, subtract weight parallel, and also subtract the friction, and that will give you what doesn't cancel out, the net force. All right, make your little chart. It is the same as last time. If you need practice, go through and think through the whole thing again yourself, or you can just look at the last example because it's still 25 kilograms and it's still on a 25-degree incline. I'm looking for the applied force. I know my weight parallel from my chart. Friction force is mu times the normal. I'm given mu. My normal force is the same as weight perpendicular, 222. The net force, F equals ma. My mass is 25. The acceleration of the object is 2.5. So at this point, it's just a math problem. Pause the video, solve it, and then see if we agree. You probably didn't show the math the way I do here, but if you screw that up, I mean, some people screw up, oh, the negative, subtracting a negative, or am I adding a negative, what do I do? Just take them over one at a time, like I did, so you don't screw up that math. I added 104 to both sides, and then I added 44.4 to both sides. It worked out. And that concludes our example problems.